Well, hello everybody. Good evening, good afternoon, good morning, wherever you are in the world. My name is Debbie Archer from ISQI, the International Software Quality Institute, and I'm delighted to have with me Fergus McLachlan from Aqua Computing. Fergus has 35 years of experience in the software testing industry and in software testing and software development. He's an accredited trainer for ISTQB training courses and also credited for the ISQI Selenium Foundation course. And I'm so thrilled that he's here with us today to talk about the potential benefits and risks of using Selenium WebDriver to test software. If you've got any questions, please pop them in the comments box in your social media feed, and we'll ask Fergus at the end of the presentation. And I know he'll be delighted to answer as many as he possibly can. So without much more delay, I'm going to pass over to Fergus and ask him to go ahead with the presentation. Sit back and enjoy, everybody. Thank you, Fergus.
Thank you very much, Debbie, and thank you everybody for joining us today. Just rearranging my screen slightly. So we're going to be looking at good practices for test automation engineers using Selenium WebDriver to automate aspects of test execution. So in terms of our scope, we're just looking at test execution tools like Selenium, and we're looking at automating through the user interface in this session. I'm using two reference points. The Selenium Tester Foundation course, I'm borrowing a couple of examples from there to demo using Python as programming language. But I'm putting it in context of the ISTQB Advanced Test Automation Engineer syllabus, talking about test automation approaches, test automation architectures. A little bit more background about myself. We will be focused on Selenium WebDriver today, but my automation experience goes back about 30 years, working with mainframe tools for a financial services company, and then moving across to a client server environment, a software house, and then a consultancy. And then finally, in the last 2 years, I've been working with Selenium WebDriver in a training context for testing browser-based applications. So I thought we would kick off straight away with a demo. I'm going to run a script that we use on the Selenium course. And it's a sort of test script for making sure that everyone is up and running with the kit. All the script does is go to the Python website and try and check that it has arrived there successfully. So I'm just going to turn across and find my script to run. See. So I'm going to type in a command to kick off the script. And let's see if we can see what's going on. Better put in the suffix so it knows I'm trying to run a Python script. It runs quite fast, so depending on response times. So essentially, the script comes back and tells us that it's started up the WebDriver for the Chrome browser. So it's opened the browser. It's then telling us that it's found the page, and it's closing off saying, yep, everything is okay. Now, let's have a quick look at the code for this. Promise not to do too much on coding today. And I'd hasten to add that when you look at job roles in software testing, not all testers will be looking at code. So test analysts ideally would not be looking at code, whereas test automation engineers would be making sure that the code is well written and providing an interface to the test analyst. So essentially, all of our code is in sort of the main line of the script. And I've used a few blank lines just to break it up a bit. So you can see line 16, we're kicking off Chrome. Line 19, we're then opening the website, and we're doing an assert. So that is a check which will pass or fail. So essential that we've got lots of asserts if we're going to use test automation tools effectively. So you can actually run this through the debugger to slow it down. You might spot actually on line 23 in light grey, I've got a sleep command which is frowned upon being used for real, but it can be quite useful in demos just to slow things down a bit. So I'm going to run it through the debugger so you can just see it running line by line. So I'm just stepping over some initial lines of code so that I can get into this function. Bear with me. Just have to click a few times, make sure I don't click one time too often. So I'm now stepping through each line of code. So issue the login command. We're now going to start Chrome. So I click on that and you'll see Chrome open. Just tab back, click on. We're now going to navigate to the web page. Bit of a pause. Just check that. There we are. We're at the Python page. And we're now doing the assert. And that's passed. And we're closing down. It's a good idea to start and end at the same place. So we close Chrome and it's gone. So that is our sort of first sort of hello world script. And I'm now just going to modify this bit. It's one I prepared earlier. So I've opened the same one, I think. Just bear with me. That's interesting. Let me close this down. Ah, it's because I haven't stopped the debugger. Right, that's better. Okay, so what's different? Well, I've decided I want to visit more than one website. So you can see that on line 18, we're going to the IceTPD website, sorry, to the Python website. On line 23, I was going to go to the ISQI website, but there was a lot of stuff happening there when I landed on the page. There was this virtual assistant called Alex who popped up. And I thought I might have a bit of trouble automating all of that. So I thought, no, I'll choose a different website that's a bit more static. So I chose the IceTPD. So what we're going to do is run this second script. Let me just move across. We're going to run it from the terminal window again. So let's just type in the script name. So it's demo 1B. Okay. And I've slowed it down. I'll put a sleep command in, so it will sleep for a couple of seconds on the Python site, and then it will go across to the IceTPD site, and then it will end. So let's see what happens. That was a bit slow. And actually, it's ended badly. There's a lot of red on the screen. So let's just quickly move across and have a look at what's happened. The assert has failed. And what it's telling us is that we were checking to see whether we had arrived at welcome to icetpd.org, but in fact, that wasn't the name of the site, and hence the assert failed. So I'm a bit lazy. I just copied that down from the Python page, but the IceTPD title is somewhat different. So where does that leave us? Let's come back to the slides. So we have challenges when we're automating on browser-based applications with tools like Selenium. So it didn't look too bad. I just copied some code. But what if you copy that code scores or hundreds of times going through the same functionality in an application? You're going to have issues around maintainability. There's also a high risk of false positives when you use browser-based tools through the GUI. So that was actually a false positive we saw. There was actually nothing wrong. We got to the website, but the way we'd set our test up was incorrect. So it was a tester error. But equally, we can have a lot of false negatives in automation where perhaps we don't put enough checks in and the script finishes and said, I didn't find anything wrong. And it's because we didn't get it to check enough things. Other things, no common logging or error handling, so no recovery handling. I think when we go back in our next demo, we'll probably find that that page is still open. So there's a lot that needs to go into designing a good automation solution. And another thought is that the test data was embedded in the script code. That wasn't too bad because there wasn't too much code. There was only sort of one line of code to read down, in sequence. But once you start multiplying that up and you've got a lot of scripts, the test analysts are not going to see their test data in the way they'd normally be able to see it and analyze it. And a final thought, which we'll come back to, is that you could see that the response times were differing a bit. I know I put some sleep commands in, but I actually think the ISTQB site was taking a bit longer than before. And with modern tools working in browser-based technologies, you have to put a lot of effort as a test automation engineer into making sure that you can observe and control the elements that you're trying to automate. So let's just have a flashback 30 years. So I worked 30 years ago in automation with green screens, where on the mainframe, it was much simpler. I just sort of click through. What I was doing was I was automating a mainframe where I was capturing the tests that I wanted to automate. So I'd key some tests through the mainframe. So back up my sort of start position, what you might call the preconditioned data, record the tests. I'd restore back to that start point, and then the automation tool would play them back. So I was using a tool called CA Verify. And there's a case study that John Kent has written about in Experiences of Test Automation, Chapter 5. This was a project we worked on together where I automated 50,000 transactions through the online part of this mainframe application. So each transaction was a pair of screens. So you would type into the green screen, nothing, there'd be no interaction with the mainframe till you hit enter, it would fire everything off, wait for the mainframe to respond. No programming at all. Fully synchronized with 5 users entering data, automatic checking of each screen, masking of expected differences, and if there were any anomalies, it was very easy to intervene and work out what's going on and recover from it. So those were the good old days of capture replay, and it would work. Now, perhaps I could have done some programming, but I didn't need to, or I got away with not doing any programming on that. So let's have a think about approaches for automation, because there are other approaches in addition to the 2 we've already looked at. So these first 2 are very similar. I certainly wouldn't recommend capture replay, capture playback on a sort of modern browser-based application, except in very limited circumstances. And the same goes for linear, because it's not scalable. You are duplicating code. There is no code reuse. And your test data is hidden. It's embedded in the code. What we're going to do in the remaining demos is have a look at a more advanced approach known as structured scripting. And we get code reuse by using a test library. We can go beyond that. We won't today. We can actually separate out the test data from the code as well. We could hold it in a number of spreadsheets, one spreadsheet for each functional area that we're automating, data-driven. Or a variant, we could be keyword-driven, where all the data is in one spreadsheet. And the first row is sort of the action that you're taking, the keyword for the data associated with it. Process-driven, taking that further, so you use keywords in business scenarios. And finally, you can do model-based testing. We're actually generating the test inputs and expected results as well. So there's a lot of approaches, and they're actually aligned to the ISTQB generic test automation architecture. So I'm going to show you a simplified version very quickly. What we've looked at, linear and capture playback, is a very simple architecture. So essentially, the framework is, in our case today, Selenium. That's what everything's sitting in. The automation solution is a very simple one, which is that when we're preparing for test execution, and the final bit of preparation, ISTQB would refer to as the test implementation part of the process, we build a test definition layer of test scripts. And there's just all these test scripts duplicating code, and then we run them. So that is essentially the most basic of architectures which can have those issues. Now, moving to structured scripting, what we're going to focus on in the last two demos is first just looking at a basic script library for code reuse. And then in the final demo, look at splitting out the execution. So there's an execution layer that's separate from that, an adaptation layer, which does all of the conversation with Selenium to automate the GUI. So very quickly, I'll build the rest of it, but it's not our focus today. So for both data-driven and process keyword-driven, then the test data is being removed from the scripts altogether effectively. And certainly for test analysts who are not familiar with programming, it means that, to all intents and purposes, they are working the same way as they've always worked, which is to define their tests and hold that, in this instance, in something like a spreadsheet. And they're not having, certainly with data-driven, keyword-driven, they're not having really to look at any code at all. And then finally, there's model-based testing, but that's a subject and a qualification in its own right. So that essentially is this idea of abstraction, which we'll talk about a bit in the remainder of the presentation, that you need to work out how much abstraction is appropriate when you're automating. There might be very limited circumstances where you can get away with not separating test data from the program code, where it doesn't have too much of an impact duplicating off program code. But if you want to protect your test assets from changes to the application code and changes to the automation code, then you move further and further up this diagram. So it's time for a second demo. Let's have a look at the Python website and the ISTQB website again. So we're going to run this next script from the terminal window. Just bear with me. But I think we'll have a quick look at it first. So I'm just going to bring it into the editor. So demo 2. So what's different about this demo 2 script? We've built on the Hello World program, but what I've done is I've removed the code that is common for actually navigating to a web page and checking the page title and doing the assert. So on lines 25 and 26, I'm doing a function call to the new page library function. And I'm passing across what I want to do. So that's the test data. I'm telling it what driver I want to use. I'm telling it, I'm giving it the name of the page that we're working with. And then we've got the actual website address. And finally, we've got the expected result that we're going to check for, which is the title of the page. So if you look at lines 11 to 11 onwards, that is our library function. And we've got code reuse. So we've now got all that code in one place. We could call it 10 times, 100 times, 1,000 times. And if we wanted to make a change, we would have one change, as opposed to potentially a huge amount of maintenance to do. So I'm going to run this from the terminal window. Let's just click across. I think I've taken the sleep commands out, so hopefully this will run fast. Hopefully it will get to completion. Hopefully I've got the expected result right this time. I think I must have left those sleep commands in there actually. So you can see that we've got a couple of messages coming back this time saying that each page is open. So that's effectively our log showing what's happened. Now we'll go into, there's more we can do. So it's not just about sort of code reuse, it's also about building very robust, high quality code. So we can do more with this now that we've got the code isolated into one library function. So let's bring in an enhanced version of this second demo. Excuse me. And what we're doing now is we're taking a screenshot. So this is quite an interesting screenshotting function. I describe it as defensive programming, starting at line 12. Just trying to drag down so I don't go too far. So where you see in bold black the try and the except, essentially what it's saying is, well, I don't know, I want to store my screenshots somewhere. It'd be nice to put them in a subdirectory in the same directory that my test scripts are in, but I don't know whether it exists or not. So that block of code, the try except, will create a directory. If there isn't one, if there is one, fine, it's there already. It takes the screenshot, and what it does, it date and timestamps it so that the screenshots are unique. And then finally, it'll put out one extra logging message, which might be a little bit over the top, but let's run that script then and see what we get now. So hopefully I've taken the sleep commands out this time. Don't think I have. I think they're still in there. So, so yes, there's one extra line in there, line 23, which is telling us each time you take a screenshot. And yes, it is useful actually putting that information out to the log because we need to know what time we took it, so to speak. So what we can do is switch across to the Explorer view. And there's my screenshots directory. And here's the ISTQB site. And here's the Python site. Okay, so let's summarize. So comparing with linear scripting, linear scripting is more scalable because of the code reuse. So that means less maintenance effectively. You can put in place enhanced logging checking. And again, you're gaining this segregation of the tester roles. You're enabling test analysts to focus more on designing the tests and associated data, and the test automation engineers can focus on the programming. So it is more usable for test analysts. What it means is you've got more programming initially, probably you're investing more money up front, but when you get it right, and there are some caveats there, but when you get it right, then less maintenance longer term. So we've got our final demo. One of our biggest challenges as test automation engineers is about the visibility and controllability of the elements we're trying to automate. And going back to my mainframe days, I was just oblivious to that because there was no visibility or controllability issue. Everything was self-synchronizing. So, it is the first step really for an automation engineer to make sure they're working alongside developers, looking at the testability of the system design. How easy is it going to be to automate? So we're going to run a library script, or create a library script, which will firstly observe a checkbox. It will sort of find it and actually look at its current state. And in the second version of the script, would actually start controlling it. And when you think about how we test, with test cases, specify preconditions, inputs to trigger a test, and expected results and post conditions. So what's going on is that when you are first observing, you're getting to a point where you're sort of checking its current state. It's in the right preconditioned state. When you're controlling, that's where you're firing inputs through. And it's not just a sequential thing. It's iterative, because once you've done some control, you've got to observe again, which is to check for your expected results. So we're going to work with a website which is live but isn't a real shopping website. It's a test website, and we're going to try and click on the small sized checkbox. I've slightly sort of simplified this screen, so there's a bit more to it than this, but in principle, we're going to land on this website, we're going to look at the state of the small size checkbox, and eventually we're going to click on it. So let's go across to the demo. So I'm going to run this first version from the script editor again. Just going to close a few things down. Click that stop button as well. So demo 3. So let's start in the main line of the code and just have a look at what we're doing. So I'm at line 28. So we're going to go to the website, the automation practice website, and we're then going to observe that checkbox. Essentially, we're going to see what its current state is. And then I'm going to engineer some manual intervention. So I've got a print command here, which will put a message to the shell area at the bottom of my screen. And it's going to give me 15 seconds to click on that checkbox. And then it's going to observe the result again. So let's see if I can do this within 15 seconds. So I'm going to click the run command, talk you through it. So it's opened the WebDriver. And we're now landing on the page. So I'm going to tab across, and I'm going to just drag down so I can click on the symbol there. So you can see the messages coming through. Click on the small size checkbox. And true is the second check. So it's gone through and said false, it's not selected. I've clicked on it, it's gone and checked again and said it's true. So if you actually look at the code, here are the two steps when you're observing in terms of visibility. You've got to locate it first. So it's finding that checkbox by its ID. Lots of different ways of finding elements, and there's pros and cons of all of them. Then it gets its state. So in our final program, what we're going to do is come up with a more sophisticated version which actually controls the checkbox as well. So where are we going to start with this? I think what we'll do is we'll go to the main line of code again. And what I've got are two function calls to this set checkbox function. So in test 1, the starting state should be that it's not selected, and I want it to stay that way. All right, so I'm passing through a parameter saying that that's how I want it to be. I want it to be unchecked. So what should happen, my expected result that I've commented to the right, is that we should see it's not selected and it's unchanged, when we come out of that function. The second test, it's still unselected, but this time in the function, I want it to be selected. So it will go in, it will see it's not selected, and it will change it. So if I take you to the function, where are we? Here we go. So I've numbered with these comments, same as before for the locate and the get. And I've put some extra logging in so that you can sort of see the state of it at this sort of second point of the get state. And then you've got the click on it. So here's the bit of code that looks at two things. It looks at what you want it to be and what it is, and make sure that when you come out, it is as you want it to be, so to speak. And it gives a final log, just giving you the after position. So let's run that from the terminal. So this time I'm not going to need to intervene. It's the function that's doing it all for me. This is 3B. I'm hoping this will be a fast. No, I've slowed this one down as well. I've slowed it down so that I can just scroll down again. I'm not going to click on it, but when we actually get the page, I'm going to scroll down so that you can just be happy that it is unchecked. So you've seen the evidence, it's unchecked at this point, and now it's checked. And I've deliberately not done my housekeeping. I've commented out sort of closing down the driver so you can see the end state there. And if I check the results in the terminal window, you can see that in test one, it was unselected before and after. It says it's false before and after. And I've just put into the log what we wanted it to be. We wanted it to be false. And in the second test, you can see it has been changed from false to true because I told it that I wanted it to be in the true condition. So let's just summarize. So we've been looking at building an abstraction in this particular exercise between the execution and adaptation layers. We're separating the high-level test scripts from the library adaptation scripts. So the test analyst focuses on the high-level scripts and test data, and if we take it further to data-driven, keyword-driven, they can end up not needing to script at all. The engineer's focus then is on controller scripts, some more technical scripts, and the test library. And critically, only adaptation scripts should really contain Selenium functions that talk to the system under test. And what this achieves is it isolates test scripts and test data from changes to the user interface, and even isolates those test scripts and test data from the situation where we might need to bring in another tool to replace Selenium in the future. So, of course, there'll be a job of work for the test automation engineer, but it should have minimal impact on the tests and the test analysts. So, in conclusion, I'm going to talk about high-level risks and benefits. So the wrong level of abstraction, this is the risk, that we go for the wrong level of abstraction, and we end up with an unmaintainable test automation solution because there's too much to maintain, and or an overly complex solution if we go too far the other way. And what ends up happening is we're just adding in project risk instead of actually achieving a lot with test automation. We might end up achieving less than if we were testing manually. Another way of putting it is we may never deliver benefit. So the blue line on my diagram is showing the cumulative cost if we were testing manually. Completely hypothetical figures, by the way, but I've got a create cost of 10 units for the manual tests. And then the gradient, as you go on from there, is the ongoing cost of running them. And if you look at the automation with linear and capture replay, perhaps a slightly higher creation cost, but not too much more so, because we're not building that infrastructure and script library. But if we have a lot of maintenance to do because the application under test is changing, and we have to keep on changing all this duplicated code, actually it never pays back. So the benefits then, when we get the right approach, if we get the optimal level of abstraction, is that we've got maintainable, usable, and performing scripts that can deliver speed and accuracy. And that's the irony of test automation, that what we're trying to do is significantly reduce product risk. But when we get it wrong, it's the other way around. We just add additional project risk. So we do get it right, then this is really the kind of curve you're looking for, which is that we're investing a lot more upfront. In my example here, the automation is 3 times. It's 3 times the equivalent manual testing effort in this hypothetical example. But the maintenance curve should be a lot flatter. So thank you again for attending today, and just checking with Debbie whether we have time for any questions.
Hello, Fergus. We have a little bit of time. We have some questions here to ask you. First of all, thank you very much for that. Use. So, Alex, can you just bring some questions up on the screen for us, please? Here we go. So, which of the automation approaches you've outlined have you found to deliver most benefit?
Well, the ones that I've used most, well, the one I've used most is actually data-driven. When I joined the software house and worked on client-server applications, we had a lot of data that we wanted to put through functional areas in the system. We were testing deep into single functional areas. So data-driven for relatively low investment of additional effort gave significant benefit there. So you could think of it, you've got 10 tests, 20 tests, 30 tests. They could be in a spreadsheet, 30 rows in a spreadsheet. And you've written, one sort of library adapter script to actually process through that area. But you can use it for things like volume testing and reliability testing. You could put thousands of scripts through with a data-driven approach. When I moved to the consultancy, to CompuWare, I've been blissfully unaware of keyword-driven. It was in its early days, so I used it a little bit there. If I had my time again, I would have wanted to do more keyword-driven. But those are the two I've used most. Going beyond that, my interest in the future is probably going to be around model-based testing, and there are tools out there to do that, and they're automating earlier parts in the test process.
Thank you. Thank you. Crack on and try to get through some of these. I know who this is. Good day, both. Good day, Keith. There's a wide range of tool options available for this type of automation. What are the positives of using Selenium?
Thanks very much for that, Keith. It's good to see you. Yes, there are a number of angles to this. One angle is whether they're vendor supplied open source or whether you write them in-house. And I'm not sure, Keith, whether that's really where you're coming from in it. So I hope I'm not sort of deflecting the question a bit. But certainly, if you look at Selenium as an open source tool, it's one of the most sort of well-known, one of the most popular, really good open source community. You've got to look at, it's still got licensing, a licensing agreement, even though you're not paying money, to other people for it. So you need to make sure that, the licensing agreement sort of fits with your particular company. So yes, there's some real positives in using Selenium for that reason. You could look at vendor supplied tools. There will be additional cost up front in terms of licensing and ongoing maintenance. So there's pros and cons. Don't want to move away too much from test automation, but there's certain tool types which you could write in-house. And the project I worked on in financial services company, we weren't just using Verify to do screen checking. We were doing full-blown file compares of the whole database at key points with an in-house tool, which was very powerful and worked very well. So yes, thank you for that one.
Thank you. When starting off in test automation, which is the best language to learn?
I'm not the best person to ask that. The only language I've used is Python, and that's because it's the language that the Selenium Tester Foundation course uses. So yes, I won't speculate, but I'm certainly very happy with Python.
Okay, thank you. Which of the automation approaches you outlined have the highest level of risk of not being fit for purpose?
Well, any of those approaches could end up not being fit for purpose, and that's the thing. I mean, up until quite recently, I was such an advocate of data-driven and keyword-driven. You would say I was somewhat biased on that front. I think, as far as capture, replay, and linear are concerned, I would be very careful about going down that route for a longer-term solution. So if you look at the context where you might use that, let's talk about linear, which was our first example. It's going to be where you're not putting a lot of data through the same parts of the application. The application is stable, it's not going to change. And once you start having all those criteria, you're going to ask, what's the point of testing it? I mean, you're going to need to do some regression testing, but you need to be very careful about going down, those early approaches. So I think personally they've got the highest risk, but there's risk around data-driven versus keyword. You've got to ask, who's the customer? The test analyst is the customer who's going to use this, and what kind of testing they're doing. So if they're doing end-to-end scenario-driven testing, then it's more likely to be a keyword-driven approach. But if you're more sort of reliability testing, heavy volumes of data, then keyword-driven could well be a sledgehammer to crack a nut, so to speak.
Thank you, Ryan Leighton, for your comment here. How do you think AI tools for test automation will affect the TAE role?
That's a good question, Ryan. And I don't have a lot of experience in that area in terms of sort of AI tools potentially. I don't know, Ryan, whether you're saying could it actually factor out the TA role. What I would say is that I've worked with people and companies for 30 years who have produced tools to automate the automation. Some really good ones, companies like Simply Testing, John Kent, many, many years ago was automating the automation. But I passionately believe, even with AI, that just as there'll always be a role for a test analyst, a critical role for this, I think there'll always be a role for a test automation engineer. Maybe we won't need so many of them, but it is that conversation and that servicing of the requirement from the test analyst, which the automation engineer needs to understand and deliver. And the point about architectures is that there's a generic architecture in the advanced level syllabus, but you're probably going to need to adapt that, just as I've shown you examples of adapting it today to these different approaches. And then you deliver solutions from that. And these solutions differ for different applications within the same company. So yes, I think the AI tools could potentially reduce the number of engineers we need or change their role, but I don't think it will remove the role.
So just a quick one on that. I think I mentioned to you, Fergus, not so long ago that ISTQB have actually released their certified tester AI testing curriculum. And I know that part of that is looking at using AI to test, as well as looking at testing AI-based systems. So an interesting one. Yeah. Alex, I think that's the last of the questions that we've got for now, and I can see that we're coming up for time. So one final shout out to everybody, please, if you've got anything you want to ask Fergus, where we're going to end the broadcast soon, so please get it in there. And Fergus, thank you very much for that, much appreciated. And I think we have your contact details. If anybody does want to get in touch with you and ask anything further, please drop us a note or contact Fergus directly. And yeah, thank you. It's really, really helpful, really useful, and great insight, and good to see a demonstration as well. Very, very lovely. So thank you. Thank you, everybody, for tuning in. Much appreciated. Take good care. Bye.
Bye for now.